Good afternoon, Manana. So now I would like to say something about electrical installations. So basically, here the electrical installation consists of batteries and LT components. LT components is like as MCB, MCCB, SFU, switch fuse unit, and types of wires, cables, so etc. etc. So these are all the LT components. So in that LT components, all these are come under this. And next topic, that is a second part in electrical installations, that is nothing but batteries. So here the batteries, applications of the batteries, how many types of the batteries, and characteristics of the batteries. Okay, so now we'll see that first of all, what is battery? Okay, so what is battery? Battery is a device. Battery is a device which converts chemical energy into electrical energy. See here, so battery is chemical energy is converted into electrical energy. Similarly, here I am taking one more thing, that is motor, generator, and transformer. So here battery I am saying chemical energy is converted into electrical energy. Similarly, motor is nothing but motor, electrical energy is converted into mechanical energy. Similarly, generator is a mechanical energy is converted into electrical energy. Whereas transformer is an principle Faraday's laws of electromagnetic induction. So here transformer is nothing but it's a static device. So what is meant by static device? Static device is nothing but it's a hard piece like a stone. So transformer is an static device which transfers electrical energy one form to another form without changing the frequency. So here basically we are discussing here the batteries. So what the battery chemical to electrical energy. So the relations of that chemical, electrical, mechanical, electrical. So that's why I discussed here motor, generator, and transformer. So basically the transformer principle and DC generator principle is both same. So transformer principle, Faraday's laws of electromagnetic induction are mutual induction. Similarly, here DC generator principle also same, Faraday's laws of electromagnetic induction. So here the Faraday's laws are two types. So what is that? First one, a magnetic flux linked with a circuit changes and EMF is induced in it. So it is nothing but the first law. And second law, the magnitude of induced EMF is equal to rate of change of flux linkage. So that is E is equal to N into d phi by dt. So, okay. So coming to point. So here the coming, what is the point? Battery. So our basic topic is battery. So battery is chemical to electrical energy. So it consists of one or more electromechanical cells, electrochemical cells. So it is used to power various vehicle devices. So what are the basic components of the battery? So here the basic components is several things: anode, cathode, electrolyte, separator. Okay, so anode indicates that minus, so it releases the electrons. So cathode indicates the plus, so it accepts the electrons. And electrolyte is nothing but medium for iron flow. And last one, separator. So separator, it prevents short circuit. So these are the basic components of the battery. So what are the things here? Basic components: anode, cathode, and electrolyte, separator. So here one more time we'll discuss that. Anode indicates that minus, so it releases the electrons. And cathode indicates the plus, it accepts the electrons. And next, electrolyte, so it is medium for iron flow. And last one, acts separator, so separator, it prevents short circuit. So these are the basic components of a battery. Next, how the battery works. How the battery works. So how the battery works, we'll see. So the chemical reaction occurs inside the battery. So the electrons flow from anode to cathode through an external circuit, produces electric current. So these are the how to batteries the working procedure. So what is that? So an chemical reaction occurs inside of the battery, and electrons flows from anode to cathode through an external circuit, and it produces the electric current. So these are the battery works procedure. Okay. Next, so here types of batteries. So basically there are two types of batteries. So what are the two types? Primary batteries, secondary batteries. Okay, so the primary batteries we can use, but non-rechargeable again. Secondary batteries, it can be rechargeable. So primary batteries used once and discarded. For example, zinc carbon alkaline batteries. So primary batteries applications is it's control, remote controls and clocks. So these are the applications of the primary batteries. Once again, we'll see that types of batteries. Basically there are two types of batteries: primary batteries and secondary batteries. Primary batteries we can use, but non-rechargeable. Again non-rechargeable, so it can use only one time. Next, secondary batteries, it can be rechargeable. Okay, so these are the primary batteries and secondary batteries. So here the primary batteries used once and discarded. For examples, zinc carbon alkaline batteries. And primary batteries applications is clocks and remote controls. So these are the primary batteries. And next we'll see that secondary batteries. So secondary batteries, it is nothing but rechargeable batteries. And for that examples is lithium ion, lead acid, and applications of the phones, laptops and vehicles. So these are the secondary batteries applications. So here I'm taking first one, lithium ion batteries. So in lithium ion batteries, so it can be widely used in modern devices. So high energy density, lightweight and rechargeable, and again rechargeable. So lead acid batteries, it is used in vehicles and low cost, reliable for high current. So these are that about that lithium iron batteries. So what are that he is saying? So it is widely used in modern devices and high energy density, lightweight and rechargeable. So lead acid batteries used in vehicles, low cost and reliable for high current. So these are that lithium iron batteries. So advantages of the batteries. So what are the advantages? So here advantages: portable power source, easy to use and available in many sizes. So these are the advantages. And disadvantages. So the disadvantages of batteries: limited of the span, environmental pollution, disposable issues. Okay. So these are the disadvantages. Now next, battery recycling. So the battery, how it will be recycling? So it reduces the pollution. When we are using the batteries, it reduces the pollution and recovers valuable materials important for environmental safety. So these are the battery recycling. And future of the batteries. So future of the batteries: solid state batteries, faster charging technology, eco-friendly alternatives. Okay. So these are the battery recycling and the future of the batteries. So here I'm taking conclusion of the batteries. So batteries are essential in modern life. Continuous improvements are being made. Sustainable uses in important battery characteristics. So here battery so many characteristics. In that I'm taking first one here, battery voltage. So what are the here the battery voltage, electrical potential difference. It may be voltage, electrical potential difference of a battery measured in volts, and it determines how much the energy hmm, each electron carries. So these are the voltage. So after that voltage, capacity, battery capacity. First one voltage in characteristics, first one voltage, second one capacity. Once again here the voltage refers the potential difference between of a battery measured in volts. So it determines how much the voltage is flowing in the electron carries. So next one, capacity. So capacity, amount of charge battery can store, measured in ampere hours or milliampere hours. So higher capacity is equal to longer usage time. What he is saying, amount of charge a battery can store, measured in ampere hours, Ah, or milliampere hours. So that is small m. So that is mAh. Next, energy density. So here energy density, so energy stored per unit weight or volume, it measured in kilos or kilos, just kilos, measured in kilos. So and energy density is equal to lighter and more compact battery. Okay. And cycle life, the cycle life, number of charge and discharge cycles a battery can undergo. So more cycles is equal to longer lifespan. Next one, power density. So here the power density, how quickly energy can be delivered. So next one, important for high power applications like electric vehicles. Next, internal resistance. So the battery internal resistance inside the battery, low resistance is equal to better performance and less heat losses. So what here the internal resistance battery resistance inside the battery, low resistance is equal to better performance and less heat loss. Next, after internal resistance, temperature characteristics. So here the temperature characteristics, battery performance, it depends on temperature. Extreme heat or cold can reduce efficiency and lifespan.